Good evening, everyone. Thank you so much for joining us today. And we'll be talking about PepsiCo's cloud and edge computing journey and some of the computer vision use cases that we're currently working on, especially on the area of anomaly detection and proactive problem solving. Yeah. And talking about myself, I'm Praseed from PepsiCo. And currently coming from a strategy and transformation team within PepsiCo. My responsibilities include managing a set of platforms based out of Kubernetes. And we work on a lot of computing, edge computing, as well as the cloud computing. We do have a large infrastructure of Kubernetes clusters spread across multi-cloud, edge, and on-premise infrastructure as well. So joining me today is my colleague Amit, and he'll be taking us through the next set of slides to begin with.
Yeah.
Over to you, Amit.
Hello, everyone. This is Amit from PepsiCo. I work as a deputy director where I'm helping team to adopt different technologies such as edge computing, IoT, containerization, Kubernetes, and recently we started our journey with AI ML as well. Now, how many of you are using edge computing in your organization? Can you please raise your hands? Good, I see a good number of people. Now, the second question, how many of you are using the same edge to learn your AI ML models? I still see some of the hands, good. I hope this session will definitely going to help you, the people who need to start their edge compute journey, and already the people who started it, and I hope it gives more insight what we are doing at PepsiCo. Now let's look at the agenda. We'll start with a brief introduction about the PepsiCo and what we do at PepsiCo. What is the motivation for considering the edge computing at PepsiCo? Then a real-time scenario where we are talking about how we are leveraging our edge. Then a detailed walkthrough on our edge platform. Then lastly, we want to share our takeaways and our learnings with you, and then we'll open the floor for the Q&A. I know, most of you heard our name, the PepsiCo. PepsiCo is one of the, or among the largest food and beverage company. There are a lot of iconic products in our catalog. Doritos, Cheetos, Lay's, Pepsi, Aquafina, 7-Up, Mountain Dew, and SodaStream. I'm sure you may be thinking, what this PepsiCo is doing is one of the food and beverage company in this as IT Tech Forum, right? Yeah. So we are from strategy and transformation team, where we come together to understand the business need, solve the complex problem, build the product from the ground, and scale it globally. S&T empowers the innovation and help adopting the different technologies across the org. Now let me walk you through the edge compute journey. I know you might have heard every spark of motivation met with a barrier that needs to be overcome. Now let's see what are the barriers for us before starting our edge compute journey. Whenever we think about the edge, first things come on our mind is limited resource or limited compute. Then the second question comes up, how can I scale it to the largest extent? Because scaling on the cloud is pretty easy. You can scale the compute just a click away. But same thing not happens with the edge. If you see in today's fast evolving world, right, the real-time data insights are very crucial, but the round-trip latencies, limited bandwidth, and connectivity, unreliable connectivity often impact our decision-making, and which cost a lot to the businesses. When we did, and on the same line, Gartner statistics said that the data which we are talking right now, right, is going to increase by 800% in coming days. Last but not least, the cost. I know. We are at the open forum where we are talking about a lot of open technologies, but still, nothing comes as a free. Because your infrastructure, your hardware, then bandwidth, and GPU. I know many of you know like how costly it is in today's day. So looking at these barriers, right, it's kind of, but at these barriers, we see an opportunity. And that's where there's one very iconic tagline from our product, that "Dar ke aage jeet hai." It comes in our mind, and that's where we started our edge compute journey. You know, we already leveraging the Kubernetes at the cloud, and we see a lot of benefits of it, like easy to scale, then management, deployment, and there are a lot of features, which is like, and we are leveraging at the fullest on the cloud. And when we did further research, like how should our edge look like, what are the problems what are people are doing, then we came across the Gartner's statistics, which suggested that the data, the 75% data, which is getting generated in the enterprise, right, that needs to be processed locally, where it gets generated before it transferring to the cloud or your data centers. So considering these points, right, what we did, we brought the Kubernetes into our edge server, and we put that edge server closer to a data source. With that, we got a lot of benefits. Like, it reduced the latency. You will have the real-time insights on the factory floors at the same place, and which help businesses take a decision faster and in better way. Not only that, we can deploy the advanced, because everyone is going towards the AI, that the next gen, the next technology is AI, right, AI/ML. So we can deploy those advanced AI/ML model on our edge, which is like running on the edge locations. Now let's see all this, and with this, right, what happens? Like, it opened the door for the immense opportunities for us, because there are a lot of day-to-day use cases that we see. And with the next short video, let me walk through what we are doing at PepsiCo. Now, you see in the first part of the video, right, there are two use cases we are talking about. The first one is on the ad management system. If you see in the ad management system, there are a lot of documentation, and the manual intervention is included, which often impact the overall operational efficiency. And the second part of the video, we are talking about the risk involved in a day-to-day operations, right, at the factory floors or warehouses and all those things. Now, let's see, by introducing the edge, how we are able to mitigate this risk and improve the overall efficiency in the remaining part of the video. Now, in this use case, if you see, we are using some of the IoT devices, such as cameras, the sensors, the buzzers, and monitoring our factory floors, and then with using the anomaly detections for accident prevention module, we are able to detect the unusual patterns and behavior which may cascade to an accident. And using this predictive analytics, right? We can predict that, okay, there are highly chances of getting an accident. So if you see, we are currently monitoring one of the factory floor where there are two things. The green part shows the safe zone, where the blue part is the risk zone. When we advise the workers, right, or employees, we say it's better to be always in the safe zone because we don't know, because there are some things like the arms moves, the robotics, and it's beyond our control. So here, by complete monitoring, like we are informing our employees, like you are at risk zone. At the same time, in the green part, right, you see one of our employee. He's there, but he's not wearing the safety gadgets, which is, again, it's a part of the violating the security policies. So similarly, there are other scenarios which you saw earlier. The overspeed of the forklift, then shelf alignment, because if the goods are not aligned properly, because in the warehouses, right, it's pretty 30, 40 feet high, and it may fall down if you're not put the goods, and we are monitoring those alignment also with our cameras. So this is how we are trying to create a safer workplace for our employees. And let's see how we are improving our operational efficiency in the remaining part of the video. Now, if you see in this use case, right, we are collecting that continuous data from our IoT devices, like cameras, then we are this display, as well as the check gates. So with this, and along with the vehicle number plate registration module, right, we completely automated the check-in and check-out process at our yard as a part of yard management system, which helped the good delivered faster and completely automated. It's saving a lot of times for the good delivery. Now, the beauty of our edge is, if you see, we are talking about the two use cases right now here, but there are many more. Running on a single edge and shared GPU. So if you see, like, it's not like only for one use case we are getting one edge server. No, it's the same edge server running the two use cases parallelly with a shared GPU. Now, let's see what empowers all these things, right? What's the main construct of our edge in the remaining part of this session? What do you proceed?
Thank you. Thank you, Amit, for giving a sneak peek into what we are really doing in PepsiCo with the computer vision use cases. And this is really a teaser, and we are doing much more. But now let's get into the details of how the edge is structured and how it is architected to empower all these capabilities, right? So this is a high-level architecture of the edge platform. So I would request your attention to the top right section first, where we are talking about the edge governance platform, right? So as I mentioned earlier, we do have a large footprint of Kubernetes clusters in PepsiCo, and which is there and at a stable platform running for several years now. So what we did was we created an in-house proprietary platform, edge governance platform, with all the core capabilities that's required for any Kubernetes multi-cluster management to run, right? And that's what you exactly see here. You do have our basic RBAC, GitOps capability. Then you do have the centralized audit and compliance capability, server management. All these are embedded into this edge governance platform. It's completely located on the cloud. It's not on edge. It's actually on cloud. And that is the governance platform managing the entire fleet of our edge clusters, which is spanned across the geography, right? And talking about the edge server, which is depicted here, this could be a single node or a multi-node based on the requirement. So what we typically do is, whenever we have a use case to get an edge cluster deployed we assess the feasibility and the requirements of that and understand whether it requires the single or a multi-node setup. And we assess what all platform components should be part of that infrastructure, right? So as you can see here, all these white boxes depicts the standard platform components which comes with the standard build, right? But not every cluster would require a GPU enabler, for example. Because a GPU enabler, we would need it only when the cluster demands an ML model deployment capability, right? So we do have this option of pick and choose from this particular list of the platform components, and then we perform the build of this cluster accordingly, right? And on top of it, we do have the standard microservices deployment and ML model deployment if there is a requirement for that particular edge cluster. And remember, all these deployment capabilities are enabled, or the application users will be leveraging it through the edge governance platform. This is going to be our single point through which all the deployments, security patches, and any configuration changes to the existing edge infrastructure will happen, right? And in this particular slide, one more aspect here is the edge devices, because you're deploying the edge cluster on the edge locations or the warehouses, and it will have seamless connectivity for the cameras, sensors, or whatever IoT devices that is actually available on the platform, right? And this really helps us to perform the real-time camera feed inferencing with the models available, or it could generate the real-time insights from the metrics that's coming out of the IoT devices, and helps us to do the real-time insights, and helps business actually take quick decisions to innovate much quicker than we do earlier, right? Yeah, now let's take a look at what we believe as part of our journey, what we understood as some of the core foundational elements of this entire architecture, right? So as Amit already mentioned or briefly touched upon, whenever we think about edge, we always think about the constrained compute that it comes with, right? So you want to do more in edge with less compute, and there is no other option. I think the right fundamental option would be to embrace, I think, lightweight Kubernetes orchestration. That's exactly the backbone of our entire architecture, right? And we know what capabilities the ML deployment at edge would unlock us, the kind of value add that will provide if we include that into the architecture, right? So that we believe that that is one of the core capability and a foundational element we wanted to put it into our architecture. And we don't want to do the operations completely in silos. We wanted a unified and a centralized management for all the edge clusters spanned across the geography. So this is also one of the core foundational element and a requirement for us. And as you can see, block storage is always a problem when it comes to edge. Unlike cloud, where you have several options available, right? So we made sure that our architecture covers a distributed block storage solution, which will ensure all your storage requirements are met. And in PepsiCo, we do have a large set of applications, legacy applications in Windows, running in edge locations as well as the warehouses. So sooner or later, we wanted all these applications to come part of our existing the edge architecture. So we wanted a capability for the platform to support Windows containers. And we are talking about the security governance aspect. We wanted this to be embraced from day one, because we know how difficult it would be to catch up at a later point, because security governance are core factors, and we need to embrace them, especially in an edge setup. There is no excuse for that. And we can do all that for a handful of clusters in a very good way, in a consistent manner. But when you talk about the scale at which we want to operate, the number of edge locations we want to extend these capabilities into, right? That's where automation comes into picture. And we wanted to embrace automation to the full extent, leveraging the GitOps as well as the ISC capabilities. Yeah. And we do have an enterprise monitoring stack and all these metrics and logs that comes out of these different edge locations, we wanted to have a channel which will plug into that centralized observability stack rather than reinventing the complete wheel. Yeah, now let's take a look at the scale, right? This is more of a depiction of different edge locations as well as the warehouses. You see, these are the warehouses and some edge locations you would see. So all are centrally managed. So I'll give you a real-time use case where the enterprise, suppose your info security team has identified that there's a security vulnerability, or maybe as part of compliance, you're asked to deploy a monitoring or an scanning agent across all your fleet of clusters, right? And how one would go about it in this particular architecture is, I think the platform administrator would get into this edge governance platform and provide the required agent or manifest in that particular platform, and then choose the downstream clusters, because that particular portal will have all downstream clusters listed. So be it based on a technology stack, or it could be based on a geography, whatever be the filtering criteria. I think the platform administrator can actually leverage that filtering option and then get that agent deployed across all the fleet of clusters selected, right? With a click of a button, maybe in a matter of minutes, you will have all these edge clusters compliant of that particular monitoring agent. So that's a kind of powerful, like, central management that we are doing for edge clusters in PepsiCo. And this is not only enabling us with only that, right? The application teams are enabled with automated provisioning, deployment, rollouts, everything in a centralized fashion, so that you get everything audited at a single place, right? And one more thing I want to touch upon here is, even though you see that there are tight integrations, maybe it would appear that there's tight integration from the central governance platform to each of these edge and warehouse locations, but it can still tolerate the minor glitches, which is something we cannot really control at times, right? Because the edge is designed to be completely autonomous in nature. What it means is, it can still serve the daily operations, what it is supposed to deliver on that particular location, or edge location, or a warehouse. But it can still catch up to the central governance platform when the connectivity restores. So it's meant to be autonomous in nature without having that tight coupleness with the central governance platform. Yeah. So this is helping us with that consistent security and governance aspect as well. Yep. Okay. I think next. All right. So having seen that, let's take a look at some of the strategic gains we had so far on this journey, right? We know it's a start, and we have a long way to go, but still, we want to share with you all what kind of strategic gains we are already reaping out of this. Yeah, I think enabling ML capabilities at the edge was something really revolutionary for us, because it unlocked a lot of value and possibilities for the entire company. We were able to perform real-time inferences out of these edge locations, and we were able to do the business decisions quickly, as I have mentioned earlier, right? So one more aspect here is the operations, because earlier, you do have all these different edge locations maintained completely by different separate teams and completely in silos. And one would know, when you want to manage a lot of clusters, and that too with different teams in silos, it will not be definitely consistent in nature. The standards will differ, the principles followed will differ. You'll have a lot of complex challenges, as well as the manpower required, right, will differ. So with this centralized architecture, we're really cutting down on all that cost, time, effort, as well as gaining on the consistent standards across the edge architecture, right? And talking about the cost saving, I think Amit briefly touched about the GPU part, right? So we want to do a lot of ML capabilities, enable a lot of ML capabilities at the edge, and that requires GPU. And everyone knows that GPUs are super costly. So what we did was we made sure that we put in a lot of focused effort to ensure all possible GPU sharing techniques are explored and implemented in our edge platforms. So be it MIG, multi-instance GPU, time slicing, and in some cases, we have even tried a combination of both to make sure that we're able to run multiple use cases with maybe a single GPU, as we have seen in the depiction of that animated video. So we are doing, enabling multiple use cases with maybe a single GPU at times, right, by doing the required due diligence for the use cases. Right. I think that's what we want to cover today. And this is more of a closing remarks. So think about edge. Think lightweight infrastructure. That's going to be your good starting point. And this is one key learning which we had in terms of, I think, operational efficiency during scale, right? Because when you think about scaling, you tend to ignore some of the day-to-day challenges in your operations. So always keep that in check and be considerate of that when you plan the scale at which you want to run your edge, right? And related to the cost factor, it's not just GPU. As we have seen in multiple sessions earlier, I think the compute with which the Kubernetes clusters are running, it's mostly not fully utilized, or not even to 50 or 60% till now, right? So we need to make sure a very focused effort is actually put in place for GPU sharing, as well as optimizing the compute resources. And plan the edge to be always autonomous in nature, because the glitches, network glitches at edge locations are something which you cannot really prevent with the current setup, right? And security compliance should be, and even the automation for that matter, should be embraced from like very initial time, so that you don't really have to catch up at a very later point, right? And we do have this hybrid approach working well for us, because we do have a large footprint of cloud or a managed Kubernetes already available. So we made sure that the governance platform run on cloud rather than deploying that on the edge to manage this, right? So this actually worked well for us. So this is some thought we wanted to share as well. Don't try too hard only to constrain everything to edge. If you have a cloud presence, try to ensure that you can take advantage of that as well, so that you can design the edge accordingly. Yeah, I think that's all we want to share today. Thank you so much. We'll open the floor for questions now. Thank you.
Yeah, thank you. So do we have any questions before concluding our session here?
Yeah.
Yeah, we are able to. Okay. Okay, very good question. Let me reiterate once again. Yeah. Is this our centralized platform is capable of deploying the complete edge, including the security patches and the complete lifecycle of the Kubernetes, right? Is that the question? Yeah. Okay. Yeah. So the question is, like, we just pushing the config through our centralized management cluster, or it's completely managing the lifecycle of the complete edge, right? In a simple form. So the answer to that, yes, we are doing both. We are pushing the configuration, and as well as we are managing the complete lifecycle. The only catch, the first time when we'll prepare the edge and we send it to our location, right, at the edge location, it will have a bare minimal requirement so that it can connect to a centralized management server over from the remote locations, and then the rest of the lifecycle get managed completely.
Yeah.
I hope that anything.
I think just to, just to add to that, right? So when a new cluster is created or onboarded, right? So you need to plug that into this particular platform. So there's one manual sort of an effort, or maybe that onboarding is the only thing you need to do. But once that is done, it's actually able to send or manage this config pushes, and even that edge cluster creation that's automated in a completely different way. Yeah. Go ahead.
Okay, can I take?
Yeah.
Yeah. So if you see in the architecture depicted, right, we have some of the agents. Let me pull back.
I think it's not.
Yeah. So this the sync agent, right, that you see, it connects with. It's always most of the time on the config part. It's a one-way direction. The edge always connects with the cloud. Cloud don't have the connectivity direct. They cannot connect that way. So our agents continuously look for those updates or anything that configuration that we have. And the protocol that you're asking, right, it's a gRPC or something else. It's a HTTPS. It's over the SSL. And that's how we are pushing our changes. And it's mostly the pullback mechanism, okay? And that's how we are putting our, not only their packages, along with the configurations as well.
Thank you.
Yeah, thank you.
Yeah. Yeah, I think the question is, are we really using some hyperscalers as part of the edge governance platform, or is it in-house built proprietary, right? So yeah, it's actually in-house built proprietary platform. We do enable some of the tools from different vendors as well, and packaged it in a way that it's very much custom to PepsiCo's requirements. That's how it's done, yeah. No, I think the OS, we do have the RHEL-based clusters for Linux requirements, and we do have Windows clusters as well run, and we do have a mix of both together, right? Because for a Windows cluster requirement, even at this date, you need a Linux node also to be part of the cluster. So we do have a hybrid mode of clusters, and mostly it's not a custom OS, it's actually off the shelf.
Yeah, adding to that, our clusters it's from the small scale to the large scale. So you can consider as a kind of Raspberry Pi also, we can manage, and as well as we can manage at any bigger one with 64 cores and all those things, right? Those servers as well. Yeah, I think.
Any other questions?
Any other question before we conclude? Yeah.
All right.
Okay.
Thank you, everyone.
If you want to connect with us, you can connect on LinkedIn. Yeah. Thanks for being with us here.
Thank you so much.